Let's look at homework exercise number 1 from section 8.4. We have some vocabulary to go over. It says fill in the blank so that each resulting statement is true. The formula A equals P times the quantity 1 plus R over N raised to the N times T power gives the amount of money in the account after the number of years is T. So in that exponent, after T years, that's the number of years, at a rate, interest rate is R in the formula, and subject to compound interest paid N times per year, okay? So again, in this formula, A equals P parentheses 1 plus R over N. It's raised to the N times T power. That's an exponent. P is the original investment. A is the future amount. R is the rate given. And N is the number of times it's compounded per year. Now, if it's annually, N equals 1. If it's semi-annually, N equals 2. If it's quarterly, N equals 4. If it's compounded monthly, N equals 12. And daily, we'll use the banker's rule, N equals 360. Instead of 365, we'll use 360. And T, again, is the number of years. Okay? So N in the formula is 1 if it's annually. Semi-annually, it's 2. If it's quarterly, N is 4. Monthly, N is 12. If it's daily, N is equal to 360. Okay, in the formula, the variable represents the amount needed to be invested now. The variable P, that's the original investment, to have accumulated dollars A in, again, T's the number of years, and the rate is R, and compounded N times per year. Now again, this formula is solved for P. So notice if you're given the future amount and you want to solve for P, you use this formula. You'd plug in the future amount A, 1 plus the rate over N, again, N times, and over, raised to the N times T power. Now, again, N is the number of times compounded per year. Annually, N is 1. Semi-annually, N is 2. Quarterly, N is 4. Monthly, N is 12. And if it's daily, N is 360 in the formula. And T is the number of years. All right, very good. Okay, determine whether the following statement is true or false. If the statement is false, make the necessary changes to produce a true statement. The formulas for compound interest so that if you make the decision to postpone certain purchases and save the money instead, small amounts of money can be turned into substantial sums over a period of years. That is definitely a true statement because compound interest is computed. Because compound interest is interest computed on the original principal as well as the accumulated interest. So you make interest on interest, so it can grow to large sums after a substantial time period. Describe the difference between simple and compound interest. Again, simple interest involves interest calculated only on the principal. Okay, you just calculated on a principal, whereas compound interest is interest compounded both on the original principal as well as the accumulated interest. So of these choices, choice C is the one there. Simple interest, that is the correct one, is interest calculated only on the principal. Compound interest is interest computed on the original principal as well as the accumulated interest. You make your interest on interest for compound interest. Let's look at question number 5. The principal represents an amount of money deposited in a savings account subject to compound interest. Find how much money will be in the account after the given number of years. Okay, so we're finding the future amount. So the formula we had, A equals the original principal times 1 plus R over N raised to the N times T power. So the original principal here is 12,000. We got the 1 in the formula plus the rate, which is 7%, so we write it as a decimal, 0.07. Annually, N is 1, so we put a 1 there. And actually, when it's annually, you don't have to put the 1 because 0.07 divided by 1 is 1. But I'm just getting you in the habit of putting in the N, because if it's not annually, then you got to substitute it in. And again, N is 1. You don't have to have it there for annually, but again, it doesn't hurt to put it to remember. And T is the number of years, so times 4. Okay, so now the good news is we can do this all in one step on our calculator. We can substitute in, we can put in 12,000 parentheses 1 plus 0.07 divided by 1 raised to the 1 times 4 power. Okay, so let's go ahead and put that into the calculator all in one step. You don't have to break it up into parts. Okay, so let's go ahead and do that. All right. So we have 12,000 is the original principal, a left paren, 1 plus 0.07 divided by 1, and then a right paren, and then the exponent, 4 times 1 power, and the amount of money in the account after 4 years, rounded to the nearest hundredth, so that's 2 decimal places, is going to be $15,729.55. Okay, how much interest? Well, what you need to do to get the interest is simply take the original, take the future amount, which is what we just got, $15,729.55, and subtract the original principal, 12,000, right? That's how much you invested. And then we would get, of course, $3,729.55. So you take your future amount, what's its value, and then subtract the original principal. So if we just check it on the calculator, we can, we can subtract answer 12,000, and we get $3,729.55. Now, again, you can also, if you want to, you can also use your fraction key, those of you that have an 84, and you can put it in as a fraction. It might be easier to see here. If I do alpha F1, and I put it in as a fraction, well, actually, this one is just a numerator, so we don't need to do this one as a fraction. We'll just go ahead and do it this way, the other ones. All right, let's go ahead and do let's go to the next exercise, number 6, and we'll practice more. The principal represents an amount of money deposited in a savings account subject to compound interest. Find how much money there will be in the account after the given number of years. So again, this formula is A, future amount, is equal to P times 1 plus R over T raised to the N times T power. So the principal is 4,000. We have 1 plus, the rate is 0.08. Quarterly is 4, so N is equal to 4 because it's quarterly. And then we have 4 times the number of years is 3 years. Okay, so there's our formula. We're going to go ahead and put it into the calculator in one step, and then you'll see what we get. Okay, so we have 4,000, 1 plus the rate, 0.08, divided by 4, a right paren, raised to the, now if you're using an old TI 83, 84 calculator, I forgot to mention on the last problem, you have to put your exponent in parentheses. So if you want to, you can put it in here too, it doesn't hurt. It's 4 times 3 power, and then there's our answer. To the nearest hundredth is 2 decimal places, so we'd round off $5,072.97. Again, the round off the nearest penny to the nearest hundredth is cents, right? 2 decimal places, so again, we have 5,072.967, so there's the hundredths. We have a 7, so we round up. That's how we round up to 5,072.97. Okay, so the amount of interest, again, we're going to subtract the original principal. So if we do it on our calculator, subtract the 4,000, the original principal, tells us how much money we made, which again, rounded to the nearest penny, would be $1,072.97. All right, very good. We're going to stop this session at problem number 6. If you have any questions, send me an email at tswers@hodges.edu or call me at 239-938-7805. Thank you.